Assalamu alaikum. Our topic is geometric sequence or geometric progression. Geometric sequence is defined as a sequence in which the first term is a non-zero number and each of the succeeding terms is formed by multiplying the previous one by a certain non-zero fixed number is called the geometric sequence. Geometric sequence is also called geometric progression is a number sequence with a common ratio between successive terms. A term in a geometric sequence can be found by multiplying the previous one by a non-zero and fixed number. And this fixed number is called the common ratio. If we call the first term of a geometric sequence A and the common ratio R, we can write a general geometric sequence as the general geometric sequence So the general geometric sequence is AR square, AR cube, A की power 4, A की power 5 and up to so on. Here A is the first term and R is the common ratio. Let me suppose a geometric progression or sequence. For example, 3, 6, 12, 24, 48 and up to so on. Here A is the first term, that is 3, and R is common difference 2. First term is 3 and the second term is 6, that is 3 multiplied by 2, and the third term is 12, 3 multiplied by 2 multiplied by 2, fourth term is 24, A multiplied by 2 multiplied by 2 multiplied by 2, and the fifth term is 48, 3 multiplied by 2 multiplied by 2 multiplied by 2 and multiplied by 2. This we say we can write 3 as 3 multiplied by 2 की power 0. We know that any number has power 0 which is equal to 1. So 3 multiplied by 1 is equal to 3. And in exponential form, this we write 6, 3 multiplied by 2 की power 1. Similarly, third term we can write 3 multiplied by 2 into 2. Base same, the rule is if base is same then we can add power. Here is 2 की power 1 and 2 की power 1. So we write 1 plus 1, 3 multiplied by 2 की power 2. Similarly, in fourth term we can write 3 multiplied by 2 की power 1, 2, 3. And 3 multiplied by 2 की power of 2 is 1, 2, 3, 4. So other term is fifth term is this we say fifth term, And the next term will be 3 multiplied by 2 की power of 2, 5. 3 multiplied by 2 की power 6 and up to so on. So by this we know the general term, nth term we can write. This is we say first term and second term, third term, fourth term, fifth term. So first term is A, T1 is A, and the second term is A, okay, the first term is 3 into 2 की power 0, second term is 3 into 2 की power 1, third term is 3 into 2 की power 2, and the fourth term is 3 into 2 की power 3, fifth term is 3 into 2 की power 4. That means if fifth term that is 2 की power less than the number of term. So similarly, if we sixth term will be 3 into 2 की power 5 less than 1, and the seventh term is 3 into 2 की power 6. So up to so on, if we nth term will be 3 is the first term A, and common ratio is R, nth term is R की power n minus 1. This is we say the general term or nth term of geometric sequence of progression. So the general term and general term formula of the geometric progression is Tn is equals to A की power n minus 1. This is called general term formula. And here n is the specific number of term. A is first term of the sequence. R is common ratio, which is a fixed number. And the standard form of arithmetic progression is given as n up to A R की power n. This is R की power n minus 1. Is known as standard form of geometric progression. Standard form of geometric progression. So the geometric progression is obtained by dividing any term by the one just preceding it. It may be noted that 0 can never be a term of a geometric progression because division by 0 is not permissible. For example, find the ninth term of the sequence 18 minus 12, 8, and up to so on. Here the first term is A, that is 18, and the common ratio we find by the formula A sub n plus 1 upon A sub n. Also, we say this term A and this term B. So B upon A is this, we got the, we used to find the common ratio. So minus 12 upon 18. And like in arithmetic progression, the common difference will be same between two consecutive terms. So here the ratio will be same when we divide the second term with first term, or we divide third term with second term. Similarly, fourth term with third term will be same if we divide second term with first term. The answer will be same as we divide the third term with second term. Third term with second term. So the ratio will be same between the all terms of the geometric sequence. So the ratio is 6.63 minus 2 upon 3, 4, 2, and 4, 3. So minus 2 upon 3 is the common ratio between the terms of the geometric progression. By using the general term formula, the general term formula, the general term formula is given as TL is equal to A R to the power n minus 1. We put the given data in the question in this formula. So here A is 18. We have to find the ninth term. So here n is 9. N is 9. T 9 term is equal to A is 18. And the ratio minus 2 upon 3. N is 9. 9 minus 1. So 18 minus 2 upon 3. 9 minus 1 is 8. 18. We put here 2 की power. We can write as with negative. We know that if sign is negative, then the power is even, then the sign will be positive. But we can describe it as power of 2 upon 3 is 8, and also minus 1 power 8. We can write as so. So 18, 2 की power 8. So 2 की power 8 is 256, and 3 power of 3 की power 8 is S. And minus 1 will be positive because power is even. So this is 1, and after multiplying and divide, we get 9 term is 5.2 upon 729. This is the 9 term of the given progression. Now we are going to start the exercise 6.4 of geometric progression. Question number 1. In question number 1, find the indicated term in each of the following geometric progression. Same as we did the example. Let's see question number 2 of part 1. Question number 1, part 2. The sequence is 32, 16, 8. And the indicated term is 9 term. So here A is first term 32, and the ratio is second term 16 divided by first term 32, 1 upon 2. Okay. And the indicated term is 9, so n is 9. So here we use the general term formula. T sub n is equal to a r to the power n minus 1, and n is 9, a is 32, r is 1 upon 2, 9 minus 1. 9 from is equal to 3, 1 upon 2 to the power 8, and 3, 1 to the power 8 and 2 to the power 8. We can write as this. We know that for simplification, we can calculate directly by calculator also. But for simplification, we know that this is 32. First term is 32. Sorry. 2 power of 2 to the power 5 is also 32. So we can write in this form also. Exponential form 2 to the power 5 is 32 and 2 to the power 3 is 8. 32 cancel with 32 and 1 upon 8 is the 9th term of the geometric progression or sequence. So the question number 1 has 10 questions. You can do easily by using general term formula. And in question number 2, find geometric progression in which the part 1 of question number 2, the third term is 10 and the fifth term is 5 upon 2 or okay. In this question we use formula of general term. That is Tn is equal to a r to power n minus 1. We know that the general term formula is this, and the given data is third term is 10. So by putting this value in the general term formula, T3 is equal to a r to power 3 minus 1, and the third term is given as 10. 10 is equal to a r to power 2. This we say equation number 1. And similarly, the fifth term is given as 5 upon 2. So we again put this data in the general term of the geometric progression. So T5 is equal to a to the power n minus 1, n is 5. And the fifth term is given as 5 upon 2. So 5 upon 2 is equal to a to the power 4. This we say equation number 2. And by dividing equation number 2 with equation number 1, fifth term with third term, that is fifth term is a to the power a r to the power 4 and second term is a r to the power 2. Fifth term is given as 5 upon 2 and the third term is given as 10. We simplify this for finding the value of r. A is cancelled with this a and the power 2 will this way we 4 minus 2. Base same में power will separate because r is in numerator and denominator. So here we get r square is equal to 5 upon 2 into 1 upon 10. So r square is equal to 1 upon 4. And we take the r is equal to, after taking root, plus minus 1 upon 2. Here we get the value of r is plus half and minus half. By putting this value, we find the sequence of the geometric progression. This is the value of r, and for getting the value of a, equation number 1 implies, equation 1 is ar square is equal to 10. So a is equal to 10 upon r square. We put the value of r here. If r is equal to plus half, so we get 10 upon 1 upon 4, that is a is equal to 40. So by putting the value of r is equal to 1 upon 2, we get the value of a 40. So if a is equal to 40 and r is equal to plus 1 upon 2, the geometric progression is a is 40. We know the journal standard form of geometric progression is known as ar square, and up to so on. So a is 40, and the second term is 40, and r is 1 upon 2, and the third term is 40, r 1 upon 2 the whole square, and up to so on. So we get the geometric progression when a is equals to 40 and r is equals to half as 40 and 20. Here we get 2, power of 2 is 4. So 4 multiplied by 40, we get here 10. This is the geometric progression when a is equals to 40 and r is equals to half. And if r is equal to minus half, so we get geometric progression as a is 40 and second term is 40 minus 40 r minus half, r is minus half, and the third term is ar square, and up to so on. The fourth term is 40 r cube. So we get the geometric progression here, 40 minus 20. Here power is even, so this sign will be positive, and we get 10. In other term, we get negative term, and alternate sign of the sign we get in with all terms. Alternate terms getting alternate sign. So this is the required sequence. So all parts of question number 2 you can, question number 2 has 2 parts. You can do with the same method. In question number 3, the question number 3 is if in a geometric progression j plus kth term is x and j minus kth term is y, prove that jth term is in radical sign the product of x, y. Solution. Let A be the first term of geometric progression and R be the common ratio. We know that the general term formula is Tn T sub n A R की power n minus 1. According to the given condition, J plus K term is X. So n is J plus K, R की power J plus K, that is the value of n minus 1. And J plus K term is X, so X is equal to A R की power J plus K minus 1. This we say our equation number 1. Similarly, the J minus K term is defined is equal to Y. So in the same general term formula, we put the n J minus K. This we say equation A, and equation A implies n is J minus K. J minus K term is A R की power J minus K minus 1. J minus K term is Y. So A R की power J minus K minus 1. This we say equation number 2. We divide equation number 2 with equation number 1. So T की power T sub J plus K upon T sub J minus K is equal to A R की power J plus K minus 1, A R की power J minus K minus 1. And the J plus K term is X and J minus K term is Y. X upon Y is equal to A is cancelled with A. And here base is same, power we add, subtract. R J plus K minus 1 minus the power J minus K minus 1. So X upon Y is equal to R J plus K minus 1 minus J plus K plus 1. Minus 1 cancel with plus 1, J with minus J, and we get R की power 2K. And the value of R is X upon Y 1 upon 2K is equal to R. Okay. We know that the J term is equal to AR J की power minus 1. By using general term formula, we get J term. This we say equation 3. And we know we find here R, and by using any equation 1 or 2, we get the value of A by putting the value of R. So we use equation J minus K term. Equation 2 implies is equal to AR J minus K minus 1. J minus K term is Y. We put the value of R, that is X upon Y. One upon 2K. 1 upon 2K. and the power is already here. Power is j minus k minus 1. So power will multiply x upon y. So here j minus k minus 1 will multiply with 1 upon 2k. So upon 2k. We find the value of a from this expression. So a y upon this x upon y power j minus k minus 1 upon twice of k is equal to a. Equation number 3 implies j term is equal to a r the power j minus 1. We put the value of a in the j term. So the value of a is this. By putting in the in equation 3 y upon x upon y की power j minus k minus 1 j minus k minus 1 upon 2k. And the power of r, value of r is x upon y one upon 2k and the power is already j minus 1. So the j term is equal to y upon x upon y की power j minus k minus 1 upon twice of k into x sorry. So y upon x upon y, and if the base same x upon y, this x upon y is the numerator and this is the denominator. So power will separate. This is j minus k minus 1 upon 2k and the power j minus 1 upon 2k. So the j term is equal to y upon x upon y. We can take LCM here 2k. J minus k minus 1 minus j minus minus plus k. So minus k plus k will cancel and plus j minus 1. So we get minus 1 upon minus j. No, minus 1 upon 2k. Sorry, there is a mistake. This is not k. This is j minus 1. So this is j minus 1. So this is j minus 1 and j minus k minus j and plus 1. Minus minus plus 1. So minus 1 is cancelled with plus 1. So we get minus k upon 2k. So the j term is y upon x upon y minus k upon 2k and k is cancelled with this k, we get the jth term is y is equal to y upon x upon y whole power minus half. So here jth term is equal to y and x upon y की power will half plus half when we write x upon y in numerator. So the value of y is 1 and the value of x is half and value of y is also half. So we get here jth term y की power 1 minus half x की power half and 1 minus half is half. Power of y is half and power of x is also half, and we have to prove that the jth term is in radical sign xy. The power of root is 1 upon 2. So the jth term is root xy. This is what we have to prove. In question number 4, which term of the sequence part 1 is 18, 12, 8 is 512, 729. We find which term, the value of n, what is the number of term 512 and upon 729. Solution. Let n be the term and we know that the general term formula Tn is equal to AR की power n minus 1. This we say equation number 1. In the given sequence, first term A is 18 and the ratio is, we find second term divided with first term. So the ratio is 2 upon 3. 6, 2, 12 and 3s are 18. 2 upon 3 is the ratio. And the nth term is given as 512 upon 729. So Tn is equal to this. Equation number 1 implies, by putting in the formula, Tn is equal to A is 18, R is 2 upon 3, n minus 1. We have to find the value of n. So 512 upon 729, 18 is multiplying with this and other side of equality will divide. So we get here 2 upon 3 the whole power n minus 1. So by simplification of this, we get 2 multiplied with 2 2s are 256 upon 729 into 2 9s are 18 is equal to 2 upon 3 whole power n minus 1. And we write 256 as 2 की power 8. And this is 3 की power 2 and 3 की power 6 and 3 की power 8. And here 2 upon 3 की power n minus 1. Okay. So 2 upon 3 की whole power 8 is equal to 2 upon 3 whole power n minus 1. By comparing the power, we get n minus 1 is equal to 8. So here 8 is equal to n minus 1, and for finding the value of n, 9. The value of n is 9. We say the required term is 9. 9 term is required. Question number 4 has 2 parts, and part 2 you can do easily with the same method of part 1. And in question number 5, if in a geometric progression the fifth term is 9 times the third term and its second term is 6, find the geometric progression. Question number 5. If in a geometric progression the fifth term is 9 times the third term and its second term is 6, find geometric progression. Let A be the first term and R be the common ratio. The general term is given as fifth term is 9 times of third term. So first we define fifth term. Therefore fifth term is A r की power 5 minus 1. Fifth term is equal to A r की power 4. This we say equation number 1, and the third term is A r की power 3 minus 1. So third term is A r square. This we say equation number 2, and according to the given condition or according to the question, the fifth term is 9 times of third terms. That means fifth term according to question. Fifth term is equal to 9 times of third term. That is, fifth term is A r की power 4 is equal to 9 A r की power 2. A is cancelled with A, and r की power 4 upon r square is equal to 9. Base same है, power will subtract. So r square is equal to 9, and we find the value of r plus minus root of 9. So we get the value of r is plus minus 3. Okay. By putting the value of r, we find the value of a. For getting the value of a, we use any equation of 2. Given equations. So, in equation number 2 implies We know that the second term T2 is equal to AR because Tn is equal to AR की power n minus 1. So this is n2 minus 1 is 1. So if R is equal to 3, in the question we given the second term is 6. So second term is 6 and R is 3. So we get the value of A is 2. The value of A is 2 and the value of R is plus 3 and minus 3. And if we put R is equal to minus 3 and second term is given in question 6. So T2 is equal to AR, second term is 6 and A and R is minus 3. So we get here the value of A is minus 2. We are putting the value of R minus 3. So if A is equal to 2 and R is equal to 3, then we get geometric progression. The standard form of geometric progression is AR square, AR cube, and up to so on. So A is 2, AR is 2 into 3, 2 into 2 3 का square whole into 2, 3 का whole cube, up to so on. So the progression is 2, 6, 3, 3, 9 into 2, 18, 54, and up to so on. Or if A is equal to minus 2 and R is equal to 3, so we get another geometric progression. If A is equal to minus 2 and R is equal to minus 3, we get geometric progression. A is minus 2, R is minus 3, minus 2 R minus 3 the whole square, minus 2 minus 3 the whole cube, and up to so on. So we get here geometric progression minus minus plus 6, 9 minus 18, minus 18 and 54. This is the required geometric progression. And similarly, in question number 6, the question is find the fifth term from the end of the geometric progression 2, 6, 8 and up to 47. Fifth term, you have to find the fifth term. So this is the same. A is given 2 in first part of question number 6 and R we can find second term divided by first term. 6 upon 2 is 3. R is value of R is 3. So we find this with the same formula. And the part 2 of question number 6 is as part 1 of question number 6. So the remaining question we discuss in next session. Thank you.